I'm Peter. I'm a machine learning engineer here at Roboflow, and I wanted to talk a little bit today about Florence-2, which is a really cool model. So I have a quick slide deck to explain some of the overviews of this model. So um, high level notes. It was released by Microsoft this year in June. It's a vision language model, which means that it has the capabilities to understand both image and text modalities, and it can sort of interact in both a spatial and visual way with images, as well as like a linguistic way. So for example, I can say, locate the phrase in this caption, a woman riding a bike, and it can respond with the coordinates of that woman in that image that has been fed to the model jointly. It's been trained over 5.4 billion annotations over 126 million images. These annotations are very like comprehensive, and there's sort of like a complex curation of these annotations that Microsoft did, and doing it over such a giant data set and such a comprehensive data set helps impart a lot of visual information to the model. It's a multiple task architecture, which means that it sort of was trained on many different tasks all at once, which gives it the ability to sort of handle a more flexible array of tasks than your traditional like YOLOs or models that are trying to do only one thing. And it's at a zero point 0.2 billion and 0.7 billion parameter size. This is sort of notable because it would be big for like a traditional computer vision model, like a YOLO, but it's a lot smaller than most language models that exist. But yeah, there's a lot of information and semantic meaning stored in these parameters, which we'll talk about shortly. So just wanted to go over quickly all the different tasks that are supported by this model out of the gate. So this is what I was trying to do. So these little phrases and angle brackets, basically that's like a unique identifier for each task that the model can do. So you can give it this identifier and the corresponding image or another piece of text as well, and the model can do uh, different things depending on what that identifier is. So just to briefly run through them, OCR would be reading text in the image. OCR with region would be reading the text from a region of the image. Then there's three levels of captioning, which would be like subtitling the image with like a description of what's going on. OD would be like object detection, so it just looks for whatever it can find in the image. Dense region caption sort of like finds a bunch of objects in the image and also captions each of the objects. Caption to phrase grounding would be I describe this image and it would find all the nouns in my description and locate them in the image. Region to segmentation, which simply you draw a bounding box and it would segment the object in that bounding box. Open vocabulary is very interesting. So you would be able to basically specify which classes you want to find, and the model could search for them. So in this case, that's the image example I have here, which is from the Florence-2 paper, where they say locate Chewbacca in the image, and it can find him. Um, then there's also all these region to etc. So region to categories classify what's in that box. Region to description would be describe what's in the box. Region to OCR would be read what's in the box. Region to proposal is sort of similar to object detection, where it just proposes a bunch of regions of interest. And then referring expression segmentation would be, I'm going to describe an object. Can you find the mask for this object? Um, yeah, so a minor correction. I think I said OCR with region is um, reading text from a proposed region, but I actually think it's finding all the text in the image and then reading the text. Okay, so that being said, I would like to show off some of these capabilities in the Roboflow app. So I have a few workflows I've defined here that can show off what this model can do. So to start out, this is sort of I think this is a really cool workflow where you take one image and you feed it to a Florence-2 model, and you give it the task type unprompted object detection, which would correspond to that open bracket OD close bracket task. And so this will just find like any objects that it's been trained to find. And then we pass it through this VLM as detector block, which will take the string that's output by this Florence-2 model and turn it into detections that we can use everywhere in the app, like your standard YOLO object detections. Um, and then we can feed those detections to a segment anything model, which will draw the masks of those detections. And we feed it to our supervision powered visualization blocks to show these detections and masks on the image, as well as the bounding box, and we draw the image. So to see what that looks like in practice, I have a image loaded up here of just like a sort of standard street view of a bunch of people walking on the street. And if we pull up what the model was able to find, so this is just with no prompting, just like find whatever you can in the image. You can see it found a lot of different people with their masks generated by Sam, a couple of pieces of footwear, as well as this sort of building here with the mask occluded by this tree, which I think is interesting, and this building here in the background. So, okay, so I think that's really cool. Like with no prompting, it's able to find a bunch of useful stuff in this image, right? But for most use cases, um, you can imagine that you want to be a bit more specific about the things you want to find, right? So let's say that I'm looking for a specific guy. Like maybe I have a description of an individual and I want to find anyone matching that description. So for instance, this guy here wearing a white jacket, or this lady here wearing a red jacket, I think you could sort of pick them out in the crowd, right? So let's see if we can find those people using a very similar workflow. So this is the same workflow as before. The only thing we've done is we've modified this Florence-2 model to use the prompted object detection task type. And we've given it a prompt of guy in white jacket and lady in orange jacket. So let's run on the same image and see what we can find. So just to show you, we're looking for this guy and this lady, right? And this is what the model returns. This bounding box is the class is guy, and then this bounding box is white jacket. And then here is lady, and the bounding box is orange jacket. So it not only did it find the people that correspond to those descriptions, it actually found their the identifiers of those people as well, which I think is really cool. And so you can imagine describing whatever object you want in natural language, and finding detections for this object could be really interesting. Like the most basic application you could think of is using this to collect data to then verify and label for a more bespoke model downstream that will run in a more performant manner. Okay, so just to give you another idea of a task that can do, I just think it's cool that it has like language capabilities. So anything that can like sort of speak about images must understand them a bit more deeply in a way, right? You couldn't have a yellow model speak about images because it would only have the context of the one object that it's looking for, right? So let's look at this workflow. So here I have, it's a very simple workflow, just a Florence-2 model with a captioning short type, captioning, and captioning long, which is just different detailed levels of captioning. And so we can run this workflow on a few images just to see sort of what things it notices, right? Because you can imagine, so here's our first image of like a mountain and some trees and some boats on a lake, right? And if we read some of the captions, for instance, the longest caption would be in this image, I can see a few boats in the water. In the background, I could see a number of trees, mountains, and the sky. And then the shortest would be a group of boats sitting on top of a lake. And then I think that, oh, maybe this is the longest one. The first one was the medium one. There are several boats in the water. There's a large mountain behind the water. There are trees on the other side of the mountain. So it can sort of talk about these images in natural English, which means that, it's finding all of these objects and it understands the relationship to each other, which can allow like a richer understanding of the image, which means that you can sort of do more complex vision tasks. So just to give another example, let's run this image of a picnic. And we can see the things the model notices. It says a table topped with fruits and pastries next to a hat. Not entirely accurate. It's not a table, so that one's a bit of a miss. But then for the longer caption, there's a white and blue striped blanket on the grass. There's a white book on top of the blanket. There are fruits on top of the blanket, which I think is really interesting. It's like starting to understand the relationship of these objects to each other. Like it understands what on top of is in this image. And again, I think something that we've seen before is that like kind of like older school deep learning methods are doing a lot more pattern matching, just looking for like the template of an object in an image under some transformation. But this is starting to really like compose the scene out of multiple objects and do a deeper understanding. So as an example of a task where maybe the model falls short, let's look at this task here. So here's the a similar workflow with the Florence-2 model configured to do text detection and recognition. So it finds all the text in an image and then it tries to read it, right? Again, we pass those outputs to detector block, which VLM as detector block, which will turn those strings generated by the model into detections. It'll parse them into supervision detections. And then we visualize the bounding box and the label of these detections. So let's see what this looks like. So we have a receipt here. So imagine for this task, you're trying to find the subtotal and the total on a receipt, right? Like this could be important if you're doing like if you're accounting for expenses or something like that, right? So let's look at the result of what Florence-2 can find. It can read a lot of this text really well, but it misses a lot of it too. In particular, I think it sort of just gives up on areas that it finds hard to read. So this sub/total line here is completely undetected by the model. Another thing is that if you wanted to extract the total and the subtotal, okay, I mean, so for instance here, we know this big bold 3421 is the total just from our experience as humans, but there's no text that signifies that it's the total, right? It doesn't say total anywhere. And this text sub/total, it's like that's a kind of non-standard spelling. We'd have to write a bunch of rules to find and identify this piece of text as representing the subtotal. And even if we did, we'd then have to like look to the right and hope that the number directly to the right is the number corresponding to that category, which could be a little brittle if the receipt is bent or rotated. So right now it can read a lot of text, but it's hard for it to actually do anything to actually extract the total and the subtotal from this receipt, right? So that's why we're offering a really cool new feature, which I'm very excited about, which is the fine tuning of Florence-2 models in the Roboflow platform. So you can see here, I've created a data set of a bunch of different receipts, and I've labeled them with a JSON. And that JSON has subtotal and total as the two fields. And then I typed in the amount of each. So here you can see the subtotal is 4432, and then the total would be 4853. And, you know, sometimes that requires a subjective judgment call. Like, for instance, here I didn't see a subtotal, so I just removed it from the JSON. People are spilling. So here, you know, balance due is the one I decided to go with for total, not just this total here. Maybe that's, yeah, maybe that's not correct from a monetary perspective, not sure. Here, so I have to understand this TL is the total, and that's 2831, right? So anyways, I created a data set. I labeled 100 receipts with these JSONs. It took me probably 40 minutes, maybe maximum. And then I trained a model. So if I wanted to train a model, I would just create a new version of this text image pairs data type. So actually I can sort of show what the project creation would look like here. So I would click new project, show more, and go down to image text pairs and give it a name and an annotation group. And if I created this project, then I would sort of get to a state like this. I think an interesting new feature is that when you create a project in the text image pairs, you get these global prefixes. So I've added a new task type, essentially mirroring the task types that Florence-2 has been trained on, where I add this new receipt task type. And then I trained a model. So if you click train model in a text image pair data set, once all the previous model checkpoints are loaded, you will be able to start selecting a Florence-2 architecture now, which is new as of Friday. So there's this new Florence-2 model architecture, and then you can choose either the base or the large size. So a technical details, we're training and distributing LoRa's here now. We're not actually fine-tuning the model directly, which means that these weights are like 8 to 10 megabytes once you've downloaded the base model. That means that these are pretty portable, and they're a lot faster to train as well. So here I have a model that I trained for 70 epochs. And you can see the loss went down starting at 6.28 for the validation loss to like, 0.04, something like that, 0.08 for the validation loss. The perplexity, which is a measure of like, if it's the perplexity measures like if it had to guess randomly, how many choices would it be guessing from? Like that's like it's as confused as guessing from 2,000 choices at the beginning of training, right? And at the beginning of end of training, it's like as confused as guessing from about 1.1 choices. So it is a really good understanding of what these text JSONs look like. So the really cool thing is that we can, I mean, I can show you how to get the workflows from here. So we click workflows, and then I have my webinar folder, and then I can load my fine-tuned Florence-2 model in workflows. So here I have this model ID already preloaded, but I can click this and see all my text image models, all my compatible Florence models. I would click that and then save it. And then now we can test this workflow on a receipt. And you can see, so this receipt has a subtotal of 55 and a total before tip of 5830. You can see the JSON. So this is sort of double JSON encoded, but if you get the JSON from this string, you can see that it's correct. And so if we look at maybe another image that was hard, so I think this one's the one. Oh, this one's the one with, yeah, sub/total and drive through as the fields, but you can see it correctly identifies the total as 3421 and the subtotal is 3124. So yeah, oh, to be clear, I also gave it this receipt prompt, which corresponds to that new task type that we introduced by fine-tuning this model. So yeah, the model became really accurate over just 100 labeled examples and maybe an hour of training time. So I think it's really cool that you can now have the capability to like directly extract a JSON from an image. So here we have subtotal and total, but you can also, since the model understands these images richly, you can imagine trying to extract more abstract information from an image in JSON format.